Hey everyone, and welcome back to the channel. Today, we're diving into a topic that sounds like it is straight out of science fiction, but is very, very real: quantum computing. So, let's start with what you already know. Every single thing your computer does. From opening a file to streaming this video is built on a simple foundation of zeros and ones. It's called binary code. A bit can either be a 0 or it can be a 1. It's a simple on or off switch. This system has powered our digital world for decades, from the first calculators to the supercomputers we have today. It's reliable, it's powerful, but it has its limits. Now imagine a switch that isn't just on or off. Imagine it could be both on and off at the same time. And not just that, but it could also be somewhere in between, in a whole spectrum of states. That's the mind-bending idea at the heart of quantum computing, instead of bits. Quantum computers use something called qubits, thanks to a quantum phenomenon called superposition. A qubit can be a 0, a 1, or both simultaneously, and it gets even weirder. Another principle, called entanglement, links two or more qubits together. Whatever happens to one instantly affects the other, no matter how far apart they are. Einstein famously called this spooky action at a distance. So, what does all this mean in practice? Well, if you have the regular bits, you have for possible combinations 00, 01, 10, and 11. A classical computer has to check them one by one. But the qubits can represent all four of those combinations at the exact same time. As you add more qubits, this power grows exponentially. A few hundred entangled qubits could hold more information than there are atoms in the known universe. This isn't just a small step up, it's a monumental leap in computing power. This incredible power allows quantum computers to solve problems that are practically impossible for even the most powerful supercomputers we have today. Think about discovering new medicines. Simulating how a complex molecule will interact with the human body is an insanely difficult task for classical computers, but a quantum computer could model it with incredible precision, potentially developing new drugs and treatments in a fraction of the time. They could also revolutionize fields like finance by creating ultra-complex risk models, or help us fight climate change by simulating weather patterns with unprecedented accuracy. And of course, there's cryptography, the very codes that protect our bank accounts, our emails, and our national security could be broken in seconds by a powerful quantum computer. This has created a race not just to build them, but also to develop new. Quantum-resistant encryption, but here's the catch: building and operating a quantum computer is incredibly difficult. Qubits are extremely fragile. The slightest vibration, a tiny change in temperature, or any stray magnetic field can disrupt their quantum state and cause errors. This phenomenon is called decoherence. That's why quantum computers are housed in these massive, super-cooled chambers that look like something from a sci-fi movie set, often kept colder than deep space. Major players like Google, IBM, and Microsoft, along with countless startups and universities, are in a global race to overcome these hurdles. They're experimenting with different types of qubits, developing better error correction techniques, and building bigger and more stable machines every year. We're still in the early days, kind of like where classical computers were back in the 1950s, but the progress is accelerating. So when will quantum computers change your daily life? It's hard to say for sure, but many experts believe we'll see significant breakthroughs within the next decade. They might not replace your laptop for browsing the web, but they'll work in the background, powering the next generation of AI, scientific discovery, and technological innovation. The quantum era is dawning, and it promises to reshape our world in ways we can only begin to imagine. Thanks so much for watching. If you found this explanation helpful, hit that like button and subscribe for more deep dives into the technology of tomorrow. Let me know in the comments what future tech you'd like to see explained next. See you in the next one.